So today we're going to go backwards of what we've done in the past couple lessons. We're going to tell you some sine, cosine, tangent, cosecant, secant, cotangent values, and we're going to ask you to find the angles. So it's really, really, really important you know your unit circle well, because not only do you need to know it forwards as we've done before, now you need to know it backwards as well. So that unit circle, get to know that really, really well. Okay. So one thing to notice here, these directions say that we want the angle to be between 0 and 2 pi. So we are looking for radian angles. Again, most of the time we are going to work in radians in this class, so please try to get really comfortable with radian angles. Okay. So let's say that we want the cosine to be 0. Well, remember on the unit circle, cosine is the x coordinate. So let's think of the unit circle. And if we want the x coordinate to be 0, let's think about where that could be. On this whole circle, there's a couple spots where the x coordinate is 0. Okay, well, the x being 0, of course, that's on the y-axis, right? If you're on the y-axis, you haven't gone anywhere horizontally, your x coordinate is 0. We've got two different angles on the unit circle where the point would be on the y-axis. Okay, so just looking at that, we would have two possibilities, either straight up or straight down. But then we also tell you something else. We also tell you that the sine is less than 0. Okay, well, sine on the unit circle is the y coordinate. So we want the y coordinate to be less than 0. We want the y to be negative. So out of these two different possibilities, we have to choose the angle that goes straight down. Okay, so this is the angle that we're looking for here, the angle that has the point on the unit circle right here. Okay, well, of course, the angle that's straight down, that would have a point on its terminal side right here. Got to know our radians. That's 3 pi over 2. Just need to know those at this point. We got to know, pi over 2 pi, 3 pi over 2, 2 pi. Okay, so that's that one. What about this one here? So we want the sine to be negative root 2 over 2. All right, well, let's just ignore the negative for a second. If we want sine to be root 2 over 2, ignore the negative for a minute. We should know what the reference angle is. Okay, we should know that there's kind of only three reference angles that we are familiar with, right? Pi over 3, pi over 4, pi over 6. So you just need to have memorized which one of those has the sine being root 2 over 2. Which one of those on the unit circle has a y coordinate of root 2 over 2. Okay, it is possible that you are remembering it as 1 over root 2. Okay, 1 over root 2 is the same thing as root 2 over 2. If you ever see something like this that you don't recognize, you could try to unrationalize it. You could get it back to this. You should kind of know 1 over root 2 and root 2 over 2 are the same thing, right? Well, one way or the other, we should recognize this. We should recognize this number is going with pi over 4. Okay, again, we need to have this first quadrant here memorized. We need to know these x and y coordinates for pi over 3, pi over 4, and pi over 6. So we should have recognized that root 2 over 2 as going with pi over 4. Okay? So that means that our reference angle is pi over 4. Okay? It's just the reference angle, though. This can't be the answer, right? We want sine to be negative. The sine of pi over 4 would be positive root 2 over 2. Okay, so now we need to do a little bit of detective work. Okay, so back to ASTC, again, probably 1,000 times in this class. Well, we know sine should be negative, so let's eliminate the first and the second quadrants. Again, all trig functions are positive in the first quadrant. Sine is positive in the second quadrant. Okay, so sine to be negative, that could be third or fourth quadrant. Well, then it tells us that tangent is positive. Okay, well, that's got to be the third quadrant then. T stands for tangent, it's positive in the third quadrant. In the fourth quadrant, tangent would be negative because only cosine is positive. Okay, all right, so now we know we're looking for an angle in the third quadrant. Let's draw it so that we can see it. Okay. So we're looking for this third quadrant angle. We know it's a third quadrant angle. Do we know anything else? Well, we do. We also know its reference angle. We know it's a pi over 4 reference angle. Okay, so what we want is this angle that goes all the way down here into the third quadrant that has a pi over 4 reference angle. Okay. Again, you might kind of just start to get to know your unit circle so that you know what this angle is. You could try to kind of count around. You could say 1 pi over 4 is here, 2 pi over 4 reduces is right there, 3 pi over 4 is right here, 4 pi over 4 reduces is right there. And so this one would be 5 pi over 4. That's our answer. Okay. You could also say, well, how do you get this angle? You go a rotation of pi plus an extra rotation of pi over 4. So you could take pi and you could add pi over 4. It's pi over 4 there. Of course, you need common denominators, 4 pi over 4 plus 1 pi over 4, 5 pi over 4. All right, so we take our reference angle that we have memorized from our unit circle knowledge, put together with some detective work of ASTC, figuring out what quadrant the angle is in, put the quadrant and the reference angle together, and get our final answer. All right, why don't you give that a try in numbers 3 and 4 there. You go ahead and try problems 3 and 4. Right, you can check your answers there. So for number 3, an x coordinate on the unit circle of root 3 over 2, you should recognize as pi over 6. Again, try to keep straight those pi over 3s and pi over 6s. That can be one that people have a little bit of trouble with because they're very similar. They're just flip-flopped, right? So keep straight which one is which. Pi over 6 is the one where the x coordinate is root 3 over 2. Right. One thing that could possibly help you is if you look at the x coordinates, they kind of go with the denominator. So 3 of denominator, you've got 1 and 2. 1 plus 2 is 3. When the 6 is the denominator, 3 and 2, 3 times 2, 6. So the x coordinates kind of go with the denominator. Could be helpful, or just memorize it. So we know pi over 6 has an x coordinate root 3 over 2. So that's how we got that reference angle. Some detective work. I will tell you it's in the second quadrant. Okay. Number 4 might have been a little bit trickier because with this tangent here, so we don't know anything. So tangent is y over x. We don't know anything where the y is root 3 and the x is 3. In fact, there's nothing on the unit circle with just a 3. It's always a root 3. So what we had to do is we had to make that 3 go away. That 3 was kind of a problem. So what we did is we unrationalized it. Some old school traditionalists had rationalized this thing. Darn rationalizing the denominator got in our way here. So we had to undo the rationalizing so we could recognize this. This root 3 over 3 started out as 1 over root 3. Okay? Well, 1 over root 3, that just had the over 2's cancel out. 1 and root 3, we know those. We know an angle that has a y of 1/2 and an x of root 3 over 2. Okay? That's our pi over 6 again. If we look on the unit circle, pi over 6 has the x of root 3 over 2, the y of 1/2. And so that gives us a reference angle together with a quadrant, and we can figure out the angle we're looking for. Okay, so those are the ones that we can do ourselves, just with our unit circle knowledge. These pi over 3, pi over 4, pi over 6 angles, plus any quadrantal angles. We can just know those based on our unit circle knowledge. But of course, there's plenty of other ones that we wouldn't just know. I don't know off the top of my head an angle that has a sine of 0.714. And so we're going to need our calculator on these next sets of problems here. Okay. So the sine function allows us to input the angle and gives us the ratio. We want to switch that around, right? We want something where I can input this number and it will output the angle. We want to switch the input and the output. And so that's when we're going to use those inverse functions, right? We're going to use an inverse function to swap the input and the output. So now we're going to input the ratio, the opposite over hypotenuse. That's what that number represents. And it will output the angle. All right. So we'll go on our calculator. All right. And then you can do second and then this button to get the inverse sine. But hold on a second. I'm about to hit that button. But before I hit that button, wait a minute. Remember, before we hit one of these buttons, what do we have to check? Always check your mode. So let me take it off a second. go into mode. Okay, how do I know which mode I want, radian or degree? Well, look at these directions here. The directions tell me that I want to be in degrees for this problem. All right, so let's switch this to degree mode. And now I can do inverse sine of 0.714. Okay, so my calculator gives me that answer of about 45.561 degrees. All right, so we got an answer. Calculator helped us out. Good to go, except it wants us to find two values, not just one. All right. Now, if we didn't say it was less than 360 degrees, actually there'd be an infinite number of answers, because you can always find coterminal angles. You could always keep adding 360 degrees. You could keep going in a full circle, and those angles would have the same trig values. But that's not what we're looking for here. All right. We want it between 0 and 360, so we can't just add 360. We can't just go in a full circle. Okay. The reason that we can find two different values and only two values in this interval is because there's two quadrants where sine is positive. Okay. So we want sine to be positive 0.714. So sine is positive in the first and second quadrants. So that means there should be an angle in each of those quadrants that has this sine value. Okay, well, we found an angle about 45 degrees. That would be in the first quadrant. So we found our first quadrant angle. So what we're looking for is our second quadrant angle. Let's draw it so we can picture it. Let's just draw a random second quadrant angle here. So here's this angle that we're looking for. Okay. So we know it's in the second quadrant. We know it has this sine value. Do we know anything else about it? We do. We know its reference angle. We know what this reference angle right here has to be. Okay. Remember, we said that angles that have the same trig values have the same reference angle. Okay. Well, 45 degrees would be its own reference angle. Okay. This is an acute quadrant 1 small little angle right here. Okay. This angle is this reference angle right here, 45.561. Okay, in order for them to have the same trig values. In order that if you drew a reference triangle right here, the opposite over hypotenuse, because this was an answer here, we know that for this angle, the opposite over hypotenuse equals 0.714. Well, we still want that to be the case. So this angle has to still be the same, so that the opposite over hypotenuse is still 0.714 if we drew in a reference triangle. Okay, well then let's try to find this angle now. Okay, so this angle plus this reference angle would equal 180. Okay, so to find the angle we want, we have to start at 180 and go backwards the 45 degrees. 180 minus this reference angle. So theta is 180 minus, and we'll say approximately because we just have approximation to this. That's 0.561 degrees. Okay, and so because that was a rounded decimal, you don't want to just type 45.561. Okay, and also that would take longer. Let's be lazy / efficient. 180 minus, there's an ants button. If you look above negative, it says ANS there. It's ants. So you can do second negative 180 minus ants and get this angle here. Okay, about 134.439 degrees. Okay. Now on these, sometimes people get a little bit mixed up if it's like 180 plus, 180 minus, 360 plus, 360 minus. The nice thing is it's really easy to check. Okay. How do we check our answer? Well, what we're trying to find? We're trying to find an angle that had a sine 0.714. So how about we find the sine of our answer, and it's 0.714. So we know we got it right. It's super easy to check these guys. It's like half a second. I mean, maybe not half a second, maybe a second or two. Take the second or two to just double check and make sure that you got the right answer. You can grade your own questions for these questions on the test. They're so easy to check. All right, it's worth doing. All right, how about this one here? Secant. Well, remember, there's no inverse secant button in our calculator. We got to just work with sine, cosine, and tangent. Okay. Now, sometimes people, what they'll do is they'll write 1 over cosine right here and try to deal with that. Usually, when people do that, they get confused. Okay. Don't change secant to 1 over. Just say if secant is this, what is cosine? Cosine is 1 over negative 3.6778. Okay, just like if I told you secant was 3/5, you would know cosine was 5/3. If I told you that secant was 7/8, cosine would be 8/7. Okay, you can go between the functions by finding the reciprocal, by flipping the fraction. Okay, don't write 1 over cosine; you'll get all mixed up. All right, so now that I know what cosine is, now I can do inverse cosine of that fraction. So the 1 over goes inside the inverse cosine. Sometimes people will do like 1 over inverse cosine. That's not what you want to do. It's inverse cosine of the 1 over, okay? And that will equal theta there, okay? And we're still in degree mode here. Make sure nobody changed it in my calculator while I wasn't looking. Always check your mode whenever using one of these 3 buttons here. So inverse cosine of 1 over negative 3.6778. All right, so we've got one answer, about 105.777, lucky sevens degrees. All right, so one answer. We need another one though, so let's be detective here. Okay. Well, we'll do our ASTC. All right, so what do we know? We know that cosine has to be negative. Okay, well, in the first quadrant, everything's positive, so that's no good. Fourth quadrant, cosine's positive, that's no good. So it has to be either the second or the third quadrant. We already found our second quadrant angle, so we're good there. So what we need is the third quadrant angle. Okay, let's go ahead and draw it. So we want this angle down here. Okay, we're looking for that angle. Okay, and so what we want to know is this reference angle. The question is, do we already know the reference angle? And unfortunately, not quite. Right? This is too big to be a reference angle. Right? Remember, reference angles have to be cute little angles. Acute. They have to be less than 90 degrees. They have to be first quadrant angles. Okay? 105 degrees, that's an obtuse angle. That's bigger than 90. That's way too big to fit right here. Okay? So this is not the reference angle. But remember, if these angles have the same trig values, they have to have the same reference angle. So whatever the reference angle is here is going to be the reference angle here. So let's draw this one. Let's draw this. Let's see, this is second quadrant. So over here, okay. So here is the 105.777, okay. Whatever its reference angle is this reference angle. Right? Because they both have to have the same adjacent over hypotenuse for this reference triangle. If I draw a reference triangle here, the adjacent over hypotenuse is this number. It has to be the same thing here. If I drew a reference triangle adjacent over hypotenuse, it has to be the same triangle. These have to be the same triangles. They have to have the same reference angle. Okay, so let's find this reference angle. Remember, we used the alpha for reference angle a lot. Okay, so if I want to find alpha, well, I want to take 180 and take out the 105.77. Okay, so alpha is about equal to 180 degrees. minus 105.777. So 180 minus, remember second negative, ants, about 74 degrees. About 74.223 degrees, okay? And so now it's the same alpha over here, okay? So this angle, what I want to do is I want to do 180 plus alpha. To find theta, I do 180 degrees plus alpha. Okay, now some of you might be seeing that there could be a shortcut of how you could have gotten here a little bit more quickly. There is a way to see this 105 degree angle in this picture and go straight to the angle that you want from the 105 degrees. If you can figure that out and do that reliably, then go ahead, that's great. The most straightforward way to solve these problems is to always find the reference angle. So I'm just going to do that. There are some shortcuts sometimes, but the most straightforward way is always find the referencing. All right, so take this here, a nice lazy slash efficient shortcut. If you just hit the plus button, just without doing anything else, just hit plus. It'll put the ants in there for you. It'll take your previous answer, ants, and then we'll add the 180, and we get our other answer. Okay, about 254.223 degrees. Okay, and then what should we do before we move on? Check it. Let's check it. Okay, so we were supposed to have a secant of that. Well, so let's find our cosine. Let's find the cosine of our answer. And then let's find the reciprocal, 1 divided by that answer. There you go. There's our secant that we wanted. We know we got this problem right. We don't have to wait for Canvas to grade our quiz for us. We know we got this question right. All right, so that was degrees. What about radians? What if we want to do this in radians? So make sure you look for the directions. Okay, the directions will always tell you whether we want radians or degrees. Okay, if there's nothing like that, then either one would be okay. But usually there will be something like this that tells you which one we're looking for. All right, so we want tangent of theta equal this. So let's switch the input and output. Instead of inputting an angle and outputting a ratio, we will input the ratio and output the angle. All right. So now I need to switch my mode to radians. And we'll do inverse tangent, negative 5.7135. All right. So we get about negative 1.398. Okay. All right, so we got one answer from our calculator, right? Actually not. We actually don't have any correct answers yet. That is not one of the correct answers. Can you see why? We wanted theta to be between 0 and 2 pi. So not only do these directions tell you that we want it to be in radians, and that to find extra answers, it has to be less than 2 pi, so we can't keep adding 2 pi or adding 360 degrees, going full circles, doing coterminal angles. It also tells you no negative angles. Okay? Because of these directions, we also know this is not a good angle. Okay? So here's the thing. What we want is basically the same angle, but positive. We want an angle in the same spot, an angle that would have the same terminal side, an angle that would have the same reference triangle, would have the same reference angle, would be in the same spot. Everything would be the same, except it would rotate differently. That's those coterminal angles. If I want an angle in the same spot, but positive, I just need a coterminal angle. What I want is, so this angle here that we had was down here, okay? And we had an angle that rotated like this to get there. That's why it's negative, okay? I don't want that. I want the angle that rotates this way in the positive direction and lands there, okay? Well, the difference between that is a full circle. Remember those coterminal angles, to find coterminal angles, we add and subtract full circles. So if I add 2 pi, If I add a full circle, I'll still land in the same spot. I'll still have the same trig value, but now I'll get a positive angle. Okay, so that's the trick. If you have a negative angle and you want it positive, just add 2 pi. Okay, it won't technically be the same angle. It'll be coterminal. It'll be an angle that has different rotation but is in the same spot. Okay, again, you can use that trick. Just hit the plus button and then 2 pi. All right, so now we have our first answer. About 4.886. Okay, no degree symbol. We're in radians now. Okay, there's our first answer. All right, 1,000 times ASTC. All right, we want tangent to be negative. We'll cross off those. We're looking for these quadrants. Okay. Now I kind of showed you here. Let's see. Do you know how I know that that's a fourth quadrant angle here? Okay. Do you remember the idea of this is pi, so it's about 3. This is 2 pi, so it's about 6. Half a pi, half of 3, it's about 1.5. And then 3 halves, 1.5. 3 plus 1.5, this is about 4.5. So this 4.8 is more than 4.5, less than 6. So it's in the fourth quadrant. Okay. So we've got our fourth quadrant angle. We're looking for our second quadrant angle. All right, so let's sketch it. So we're looking for this angle here. And what we want is the reference angle. That's how we always find these angles, the reference angle. Okay? Do we know the reference angle? Remember, the reference angle has to be acute little angle, a first quadrant angle. Okay? Less than 90 degrees, less than pi over 2. Okay? So it can't be this. This is a large angle. I know, 4 point something with degrees, that would be super small. Doesn't look like a big number, but in radians, that's very large. Okay, that would be in degrees. That would be something around what, like 300 degrees, something like that. Okay, it's a fourth quadrant angle. This is a large angle. It can't be the little reference angle in here. Okay, we actually do have the reference angle already, though. It was this 1.398. Okay, that is less than pi over 2. That's less than 1.5. Okay, remember this picture right here, this negative angle was the angle to rotate backwards to land here. Look at that small little angle. That would be its own reference angle here. Okay, that little angle there. We have that. If we draw the reference triangle right here, this angle that we had is this angle right here. Okay, so to find our angle, well, looks like we need to do pi. Remember, it's not 180 anymore. We're in radians now. We need to do pi and go backwards 1.398. Pi backwards. Okay. So pi minus this 1.398. All right. Well, let's see. In my calculator, let me go back. I've got it as negative in my calculator. So to do pi minus, I actually want to do pi plus the negative 1.398. Okay. And that give me my other answer. Okay, so I want this plus pi. And this gives me my other answer. Well, a little bit trickier in radians, so we should definitely check our answer. Let's find tangent of that answer. There we go. We've got the correct tangent. Okay, a little bit of rounding error because I just copied that answer down. Okay, when you do the whole, so I just used my up arrows and then I went here and I hit enter to grab that. That doesn't quite get the exact value. There's a little bit of rounding error there. So that's why we're just slightly off right there. Okay, if you really wanted to find the exact, you could go back and you could do this again and take that exact answer and add it to pi. Then find tangent of that answer, and that one works out perfectly. All right, why don't you go ahead and give one of these a try here. Go ahead and try number 2. A little bit trickier in radians. See if you can get it. Go ahead and give number 2 a try. All right, that one wasn't too bad. The calculator gives you a good answer, and it is the reference angle. It's less than 1.5. It's less than pi over 2. So it was the reference angle. And so you just needed that second quadrant angle there, pi minus that reference angle. And then you're good to go. Hopefully you checked your answers already, actually. You can check them on the screen right there, but hopefully you had checked your answer already and knew that you got that problem right.